Hello everyone. So this is question number one of our continuity and differentiability test. Okay. So this is the question. If f of x equals to x into mod of x, then f of x at x equals to 0 is continuous and differentiable. And like we need to find out whether it is continuous function or differentiable function, right? So here for this particular f of x, we need to check whether it is continuous or differentiable. But first, let us try to recall the concept of continuous, like so continuity of a particular function. The function f of x is said to be continuous at x equals to a if it satisfies the following condition. Only these three conditions are there in order to be a function to be continuous. First thing is that f of a must be defined, right? So f of a must be defined. It means that if I just replace x by a, so I should get a finite value, right? What about second option? Limit x tends to a, f of x must exist. So limit should exist for this particular f of x. When we can say limit exists when left hand limit is equals to right hand limit. And here you can say x tends to a negative. That is basically a left hand limit, and x tends to a plus, that is basically a right hand limit. If left hand limit is equals to right hand limit, then we can say our limit exists, right? Limit of a particular f of x exists. And then limit x tends to a, f of x equals to f of a, right? So limit x tends to a, f of x, that value must be equals to f of a. So if I just replace x by a, I should get the f of a as a value, and it should be equals to the limit of this particular function, right? So simple thing is that for any continuous function, you just need to satisfy these 2 points, second and third, right? So first thing is that limit should exist, and the value of that particular limit should be my f of a, right? Simple. So for every function to be continuous, there are only two requirements. First thing is that limit should exist. It means that left hand limit must be equals to right hand limit, right? And that limit must be equals to f of a, right? That's it only. Now let's try to apply same condition to this particular f of x. Now here my f of x is x into mod of x, right? But first we should understand what is this mod of x function is. So this mod function is very important for GATE exam point of view, because like almost every year you can see a question based on mod of x in the case of continuous or differentiability. Okay, either in any of the paper, but one question will be there, like in any branch, right? So if I just plot the graph of f of x equals to just mod of x, so it will be like this, right? So it will meet at this particular origin 0 comma 0, right? So what we can say from this particular graph? So when x is greater than or equals to 0, my f of x equals to x, right? And when x is less than 0, then f of x is basically minus x, right? So please remember these two important points. When x is greater than 0 or equal to 0, my f of x is positive, that is x. When x is less than 0, my f of x is negative, that is minus x. Okay, so this is what mod function is, mod of x. So only this concept is required to solve any type of problem. Okay, because next question is also based on this, so we are going to apply the same concept there only. Okay, now try to apply the same condition to this particular f of x, right? So now what I can say, f of x equals to x into mod of x, right? So mod of x will be x when x is greater than or equal to 0, and it is equal to x into minus of x when x is less than 0, right? So it will be minus x square, and this will be x square only, right? Now this is my function, f of x equals to x square when x greater than 0, and it is minus x square when x less than 0. That's it, right? Now first we need to check whether it is continuous or not. So for that, limit should exist. So when we can say limit exists when left hand limit is equals to right hand limit, right? So if I just consider left hand limit, right, it means my limit x tends to a negative. A negative means I am going to this particular point or any point from the left hand side. So suppose this is my any function, right? This is f of x, continuous function, right? And this is my point. Say for example, this is a. So I can reach this particular point in two ways. Either I can go from left hand side in this direction, or I can go from right hand side from this particular direction, right? So I can reach this particular point A from two sides, either from left hand side or right hand side. And if I go from any direction and that value is equal, then we can say limit exists, right? So it is true for any continuous function. Please remember this point, right? So a negative means I am going from left hand side up to this particular point, right? So what this limit x tends to a here, that is basically a f of x, right? So x tends to a negative. So it means I am going from left hand side, right? So it will be less than 0 in this case for f of x, right? So my this particular function, the value of this f of x when I going from a negative will be my this negative, right? So minus x square, that is limit x tends to 0 minus x square. So value of this particular limit is 0. What about right hand limit? Same thing, limit x tends to 0 plus x square, and the value will be also 0. So here my left hand limit equals to right hand limit, right? So limit exists, right? So limit exists. And what is f of 0 here? So f of 0 will be 0 into mod of 0 will be 0. So that is 0 only. And here you can see my limit exists and that limit is equals to f of a. That is f of 0 in this case. So I can say my both the conditions are satisfied for a continuity function, for a continuous function. So I can say my is f of x is continuous, right? So f of x is continuous. So either option A or B can be correct because not continuous. So I can eliminate this. Neither continuous. So I can eliminate this, right? So my f of x is continuous. Now we have to discuss whether it is differentiable or not. So now let us discuss about the differentiability. So f of x is said to be differentiable at a particular point x equals to a, that is given by f dash of a, if this particular limit exists. Okay. So that is limit h tends to 0, f of a plus h minus f of a divided by h. So if this particular limit exists, so the value of this particular limit will be my derivative of this particular f of x, and I can say the function is differentiable. So the value of this particular limit will be my the derivative of this f of x, right? So here you can see, right? So in our case, f of x is basically x square, and it is minus x square when x is less than 0, and it is when x is greater than or equals to 0, right? Now same thing here we need to apply. We need to check whether limit exists or not, right? That's it. So we need to check whether this particular limit exists or not. So limit h tends to 0 negative. So just replace x by a plus h. So what is a in our case? That is a equals to 0 because here we need to find out at x equals to 0, right? So our a equals to 0, right? That is f of h only. That is f of h minus f of 0 divided by h, right? So limit h tends to 0 negative and f of h will be just replace x by h. So because we are going from left hand side, so we need to take this particular function minus x square. So minus h square minus of minus 0, right? Divided by h. So the answer will be, so h will get cancelled. That will be a minus h. And if I just put 0 here, so instead of h we need to put 0 because for this particular limit. So it will be 0, right? So left hand limit is basically 0. What about right hand limit? Same thing, right? Limit x tends to 0 plus. So f of h will be in this case just replace x by h, that is h square, right? Minus of f of 0 will be just 0, right? And here divide by h. So what I will get here, that is basically h only, right? So if I just replace x by 0, so I will get 0. So here you can say our limit exists. So I can say this particular function f of x equals to x into mod of x is differentiable because both left hand limit and right hand limit exist, okay, for this particular limit, and the value of this particular differentiable, that is f dash of x, is basically a 0, okay. So the value of this particular limit will be the derivative of this particular function f of x. So our correct option is option number A, that is continuous and differentiable. So in this way you need to proceed for each and every question, whether it is continuous or it is differentiable, right? So I hope you understand the concept of continuity and differentiability. Okay, so this is question number 2. The function y equals to mod of 2 minus 3x, right? So we need to check whether it is continuous or differentiable, right? So in the previous example, we have discussed about y equals to mod of x, right? So we know that it is continuous for all x belonging to R, but not differentiable, right? But not differentiable. Now what about this particular function y equals to mod of 2 minus 3x, right? So instead of x we have 2 minus 3x here, right? So what is the critical point for this particular expression? It's y equals to 2.3x. Critical point means where my y coordinate will become 0. So that is basically y equals to 2 minus 3x equals to 0, right? So it means 2 equals to 3x and x equals to 2 by 3, right? So we know the graph of y equals to mod x is like this. But we have shifted the point to 2 by 3 here in this case. So suppose I say this is 2 by 3. So my graph for this particular function y equals to mod of 2 minus 3x will be like this. Okay. This is y and this is x. Okay. Now it is continuous everywhere, right? So for all the value of x similar to x, a mod of x function, it is continuous. So for all the x belonging to R, right? But it is not differentiable except at x equals to 2 by 3, right? That is here you can sharp corner is there, right? Sharp corner, right? So, but it is not differentiable at x equals to 2 by 3, right? So only option C is correct. By looking at this particular graph or this function, we can say it is continuous for all x belonging to R, right? But whether it is differentiable or not. So since mod of x is not differentiable at x equals to 0, so this will not be differentiable at x equals to 2 by 3. So directly we can conclude this because we already know this particular concept, right? So I can say option C is correct, right? And also remember one important point. Suppose if I have graph like this, okay, so these are the sharp edges, right? Sharp corner here, right? Sharp corner. So function is not differentiable at those particular point, okay? If our graph is having this particular sharp corner like this, so function is not differentiable at this particular point. Suppose it is A, B, this is C, D, and E, and this is f of x. So this f of x is continuous everywhere. Okay, we can say it is continuous everywhere, but it is not differentiable at x equals to A, B, C, D, and E because we have the sharp edges, right? So why it is not differentiable? So if I just draw a tangent to this particular point, it will be a straight line, right? Like this, right? So it is not differentiable at this particular point where the graph is having these sharp edges, right? So please remember these important points. So it is not differentiable where the graph is having the sharp edges. So also directly we can say if at this particular point it is not differentiable, that is basically x equals to 2 by 3. So option C is correct and remember this important point, okay? That function is not differentiable when the graph is having the sharp edges, okay? Okay, so this question number 3, right? F of x is given to us and x is not equals to 0, right? And it is continuous, right? Then the a equals to 1, okay? Okay, so this function is like this, right? So f of x equals to sine square a of x divided by x square. So when x is not equals to 0 and when equals to 1 when x is equals to 0, right? And is continuous, and we have given that this particular function is continuous, then find out the value of a, right? So same thing you have to apply for a function to be continuous. There are only two things. First thing is limit should exist, right? Limit should exist, and second thing is that the value of that particular limit, that is limit x tends to a, f of x must be equals to f of a, right? These two condition must satisfied. So we can directly apply this particular condition, right? Right, so here we know, okay, so f of x equals to 1 when x equals to 0, right? So it is continuous. So can I say limit x tends to 0, right? So f of x will be equals to 1, right? Because at this particular x equals to 0 it is continuous and the value of that particular function is 1, right? So same thing I can say, right? So if I just put f of x here, so limit x tends to 0, f of x is basically sine square ax divided by x square, right? So equals to 1. So we just need to find out the value of this particular limit and equate to 1, right? So if you know the concept of limit, property of limit x tends to 0, sine of x divided by x is basically a 1, right? So can I use this particular property here? It means that the coefficient of this particular x and this x would be same, right? So it is 1, that's why it is 1, right? So if I just replace, so if I just multiply or divide by a, so multiply by a and divide by a. So can I write like this, limit x tends to 0, a into sine square ax divided by ax. Okay, so ax square, right? So here we need to multiply by square. That is square only, right? That is square square. So what I will get? A square into sine of ax divided by ax square, right? So now limit x tends to what? 0, right? So we know. So limit sine of ax divided by ax, that is x tends to 0. This is equals to 1, right? So if I just put this value of this, so it will be a square, right? Now here a square equals to 1. So here a square equals to 1. So what I can say, a equals to plus minus 1, right? So value of a will be plus minus 1 and option B is correct. Okay. So I have used this particular second property, that is limit x tends to a, f of x equals to f of a. So in the question it is given that it is continuous, right? And the value of that particular function f of x equals to 1 when x equals to 0. So that's it. This is the only required information I want. Right, so if I just apply this particular concept, I can solve this particular question. But here you should know the property of a limit. So I have shared the properties of a limit in the notes. So please go through it. It will be very useful for you. Okay. Okay. Now let's solve this particular question. So same thing, like what should be the value of lambda such that function defined below is continuous, right? So it is pi by 2. Okay. So this function is given to us and it is continuous. Continuous means limit x tends to a, f of x must be equals to f of a. That's it, right? Now same thing you can apply here for x equals to pi by 2. So limit x tends to pi by 2. Okay, for this particular function will be lambda cos of x pi by 2 minus x, and the value of this particular limit is equals to 1 because the function is continuous, right? Now let's try to solve this particular limit. So if I just put pi by 2 instead of x, what I will get? Lambda cos of pi by 2 minus pi by 2, right? So it is 0 by 0 form. So it means we need to apply L'Hospital rule. So just take the differentiation of numerator and denominator separately. So what I will get? Limit x tends to pi by 2. Lambda is a constant, right? So derivative of cos x is minus sin x, right? And derivative of pi by 2 minus x is basically minus 1. Minus minus will get cancelled. We have lambda sin x. Okay. So just put the value of pi by 2 in the x. So we'll get lambda into sine of pi by 2. This is basically equals to 1. So lambda equals to 1. Simple, right? So the value of lambda is equals to 1. That's it. Now what about this particular question? So the function mod of x cube, right? So where x is a real function, f of x at x equals to 0 is. So same thing, you can directly take, as we know that f of x equals to mod x is continuous but not differentiable, right? But not differentiable at x equals to 0, right? So if you take any polynomial in mod of x, it will be continuous for sure, right? So we need to check whether it is continuous and differentiable or not. And here also, if you see the option number C, it is once differentiable but not twice. So we can see that also, right? Now let's try to solve this particular question. So we know that this particular mod of x is continuous at x equals to 0. So any polynomial in mod of x will be a continuous function, right? But we can check for differentiability. So same thing, limit h tends to 0, f of a plus h minus f of a divided by h, right? So same thing, just replace x by a plus h, and here a is equals to 0, right? So what will be the limit? H tends to 0, f of h minus f of 0 divided by h, right? So same thing we can calculate, as we know that mod of x cube equals to x cube when x is greater than or equals to 0, it equal to minus x cube when x is less than or equal to 0, right? Same thing. Now just try to solve this particular limit. So limit h tends to 0 negative, that is left hand side limit will be minus h cube minus of 0 divided by h. So h will get cancelled, that is minus h square, it will be a 0.
Same for left hand limit, right? So limit h tends to 0 plus, that is right hand limit. Instead of h will be x cube, that is h cube, minus f of 0, that is basically a 0, right? Divided by h, so again h square, so it will be again 0. So here you can see it is differentiable at x equals to 0, right? So option B will be correct. Okay, so consider the following two statement about function f of x equals to mod x. So we already discussed this. So f of x is continuous for all real values. Yes, P is correct. What about Q? F of x is continuous for all real values. No, this is not correct because it is not differentiable at x equals to 0, right? So P is true and Q is false. So option A is correct. Okay, so now about this particular question, right? So this is question number 7, I guess. Yeah. So here we are saying y equals to mod of x for x less than 0, right? So this is x, this is y, this is less than 0, that is mod of x. So it will be like this, right? And y equals to x. So y equals to x is like this line, like here you can see it is greater than 0. So in short, I can say this y equals to mod of x only, right? Because this graph is similar to the mod of x function only, right? So dy by dx is discontinuous as at x equals to 0. Yes, because it is not differentiable at x equals to 0. We have discussed this, so option A will be correct. Dy by dx is continuous. No, it is not continuous. Y is discontinuous. No, it is not discontinuous. So both it is also not correct. So only option A is correct. So simple concept based on this particular function only. Now what about this question number 8? Okay. So same thing. We know that this function is not differentiable at x equals to 0. This is not differentiable at x equals to minus 1. This is not differentiable at x equals to 2. So correct option will be option number C only, right? It is this one. Simple. You can solve this question within 1 minute. Okay. So question number 9. So find the value of a and b such that the function defined by this f of x is continuous. So same thing. If this is continuous, right? So I can say limit x tends to a, f of x equals to f of a, right? So same concept we can apply here. So here we can say, okay, if limit x tends to 2, right? Value of f of x is equals to 5. If ax plus b, then from 2 to 10, the value of ax plus b is equals to this equals to 21 if x is greater than 10, right? So I can say, right, it is equals to 2 and here also is less than 2. So I can say this limit x tends to 2, ax plus b will be equals to 5, right? So if I just put the value of x here, that is twice a plus b equals to 5, right? This is equation number 1. Now here you can see 21 greater than equal to 10 and here it is less than or equal to 10, right? So I can say limit x tend to 10, ax plus b equals to 21. Right, so again I can put x value of x here, that is 10a plus b equals to 21. Question number 2, try to solve this question, try to solve this equation simultaneously. So we multiply 5 by equation 1, okay, then minus equation 2, right? So multiply by 5, multiply 5 by equation 1 and then minus 2. So what I will get, 10a plus 5b equals to 25 minus of 10a plus b equals to 21. So minus minus minus, so this will get cancelled. It is 4 of b equals to 4. So b equals to 1, right? Just put the value of b in this equation. So what I will get, 2 into a plus 1 equals to 5. So 2a equals to 4. So value of a equals to 2. So value of a equals to 2, right? And b equals to 1. Simple as that. Okay. So just one thing to remember, when x tends to 2, it is this function is continuous and the value of this particular function at x equal to 2 is this. So I can equate this, right? What about this? Or what about, so how we got this particular second equation? When x tends to 10, the value of this particular function is this one. And when it is equal to 10, so value of function is 21. So from here I will get second equation. I can solve this equation simultaneously and the value of a equals to 2 and b equals to 1, right? Okay, similar question, question number 10, right? Find the values of k so that function f is continuous. Same thing, same. Here you can see x is less than or equal to pi, but x is greater than pi, right? At x equals to pi. Similarly, limit x tends to pi, that is basically a cos of x. This must be equals to limit x tends to pi kx plus 1. Solve both the limit. Cos of pi will be cos of pi. What is the value of cos pi here? That is minus 1, right? It is minus 1. And what about limit x tends to pi? So it will be pi x, sorry, pi k plus 1. So, right? So I will go, it will go on this side, that will be minus 2 pi k. So the value of k will be minus 2 by pi, right? That's it. This is question number 10. So I hope you understand the concept of continuous and differentiability, continuity and differentiability, and how to solve the questions. Okay. So, and you can expect this mod function very important. Different types of question can be framed, but the concept of mod should be clear, right? So just remember two things: for continuous function, those two requirements must be there, and for differentiability, limit x tends to h, f of a plus h minus f of a divided by h must be exist, and value of that particular and value of this particular limit will be my derivative of this f of x, right? So please remember these two important thing about continuous and differentiability. Okay, thank you.